Okay, continuing on for section 3.1, talking about extreme values, and we have a couple examples to go. So, example number 4 is where I left off, and what is our function? Sine x, cosine x, and we're looking at the interval from 0 to pi over 2. Well, individually, each of these functions are continuous. So if I take a continuous function kind of times a continuous function, I'll get a continuous function. This domain then is negative infinity to infinity. We have a continuous function. And for the EVT to apply, I need not only a continuous function, got it, right? We have that. But we also need it to be on a closed interval. Why must it be on a closed interval? Well, the deal with the closed interval is that it guarantees that there is a max or a min, because if nothing else, if I didn't have my first derivative equaling 0 or undefined any spots along the path between 0 and pi over 2, well, then at least I can be assured that wherever it started and stopped could be a max or a min. So that's the importance of having the closed intervals. So what are my endpoints? The endpoints are x equals 0 and also x equals pi over 2. So those are candidates for possible extreme values. Let's find our critical numbers. The critical numbers, remember, come from f prime of x equaling 0 or f prime of x not existing, so where it doesn't exist. If we take the derivative of sine and cosine, you would do a product rule. It turns out, just to keep this shorter, I get x squared minus sine squared. I think I said x squared. Cosine squared minus sine squared. And set that equal to 0, cosine squared x minus sine squared x. And you're probably thinking, well, how in the world am I going to do that? Let's bring over the sign. Let's say sine squared x equal cosine squared x, and see if this takes us in any direction. Well, I could say I've got sine of x quantity squared equals cosine of x quantity squared, couldn't I? And those would be equal. Well, think of your unit circle. Where is sine and cosine equal? Well, they're equal in quadrant 1 and 4. Or, I'm sorry, 1 and 3. In quadrant 1, we'd end up with pi over 4. In quadrant 3, I would end up with 5 pi over 4. But 5 pi over 4 is out of our range from 0 to pi over 2. So in the range 0 to pi over 2, you know what? It's going to be pi over 4, isn't it? And then where does the derivative not exist? Well, the derivative is cosine squared minus sine squared. That's going to exist everywhere, because if I have a continuous function minus a continuous function, I get a continuous function that has no jumps, skips, gaps, all of that business. So differentiable everywhere. We need 2. These are our candidates. The candidates, dun, da, 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 candidates for extreme values would be our endpoints at 0 and pi over 2, and our one critical value that we found, our critical number at pi over 4. Throw those into the original function, and it will look like what? F of 0 equals, is a good spot to do it, sine of 0 cosine of 0. Well, the sine of 0 is 0, so this is going to come out to be 0. Once again, f of 0, f of pi over 4 would be sine pi over 4 times cosine pi over 4. That'd be square root 2 over 2 times square root 2 over 2. I'd have 2 over 4, which would give us 1/2. Finally, let's check out pi over 2, which equals sine of pi over 2, cosine of pi over 2. Multiply those results. I'd have a 1 times a 0 gives me 0. So I can see from this that I have an absolute maximum value of 1/2. I have an absolute minimum value twice, don't I? Absolute min value of 0. And I also over here have an absolute min value of 0. One occurs at x equals pi over 2, and the other min value occurs at x equals 0. Example 5, determine if the EBT applies for each of these functions. If so, find the extrema. If not, explicitly state why, and then determine if the function happens to still have extreme values. If f is continuous on the closed interval, then, and it's got to be continuous, this is really the EBT, isn't it? Extreme value theorem, that f has both a minimum and a maximum. These are talking, when they just say min and max, we're talking absolute min, absolute max. Often they'll just shortcut it to say min and max. All right, so on this closed interval, can I apply the EBT? EBT does not apply in this case. Do you know why? Function's not, because I'm just going to call it f of x. F of x is not continuous. In the interval, -2 to 1. We got to jump here at 1, don't we? So, do we have a min and a max? Well, we would have a max, no max on this because of the open circle up here. There is a min. The min is 0. Min is 0 at x equals 2. But the EBT would not apply. It doesn't guarantee that there's both a min and a max, and in fact, there was not a maximum on that one. On this one, do we have the EBT? Can the EBT apply? EBT does not apply. Do you know why? Well, it doesn't apply because it's not on a closed interval. Because not a closed, that looks funny, doesn't it? Not a closed interval. We would be open interval, looks like it'd be open 0 to open 2. So there doesn't have to exist a min and a max. And actually in this case, we have no max and no min. We've got open circle to approaching infinity here. So neither have it. In this one, does the EBT apply? Oh, no, we got EBT does not apply. We have the discontinuity due to discontinuity at x equals 1, which is in our interval from 0 to 2. We do have the closed interval, but we don't have the continuity. Is there a max? Yeah, there actually is. There is a max of 3. A max of 3 at x equals 2. Is there a min? Actually, there is. There is a min of 1/2, let's estimate, at x equals 0. So I think you get the picture. I'm going to skip the next one just to save some time. On the back side, the difference between extreme value and the location of the extreme value, if you're asked to find the minimum or the maximum of the function, they're asking for a y value. If you're asked at which x does it exist for a min and max, then of course they want the x value. If you're asked at which point does this function have min or max, well now a point is an ordered pair, isn't it? They're looking for both the x and the y. So just read carefully so you answer the question correctly. So example 6, I'm going to let you do it on your own. Do your derivative and check it out. This will come back on. I had that a g of x had a max of 8 at x equals 2, just so you can check your answers, and it had a min of -3 at x equals 1. Be sure you check each endpoint, and then be sure you check for your critical values using those criteria. Homework is this next section, and it's page 169.